First, we will demonstrate the Y790s data acquisition and storage software functions. Physical connection part. We insert the TF card containing the boot bin file into the TF card slot. Adjust the dip switch to TF card boot mode. Connect one end of the 100G fiber optic cable to the first QSFP28 interface of the Y790s. The other end connects to the first fiber optic interface of the FX200. Then connect the serial cable and the 12V8 5A power supply. Then connect one of the two antennas to the RX0 RF channel. Another connection is to the TX0 RF channel. Next, we will demonstrate the data acquisition and storage software operations section. First, let us introduce the software interface of the data acquisition and storage software. The software is divided into 6 regions. The top left is the spectrum display area. The middle area is the waterfall display area. Below is the software's log section. You can view some of the software's running status. You can set some software parameters at the top right. The first column lists the software's basic settings. It involves setting up the device. A reference clock can be set. VCO, FDD, TDD modes, RX antenna, enabled or disabled. Then, the signal bandwidth is set by adjusting the sampling rate. Set deck voltage and PPS mode. The middle part is the software's data collection. At the bottom are the software's playback settings. After powering on, we click to turn on the device. You can see it in the log section. The board has now been successfully opened. We are currently using an 8-channel device. The software will automatically recognize the number of channels on the device. The settings at the top, the capture settings in the middle, and the playback settings at the bottom are for repeating the settings. It's clear that the device has 8 channels. Next is RF0 to RF7. This involves setting the radio frequency parameters of the software. You can set the transmit frequency, receive frequency, transmit attenuation, and receive gain, bandwidth for sending and receiving. The last column is for configuring the spectrum plot. You can set the size of each grid in the spectrum plot. Display settings such as resolution. Then collect settings. The receiving antenna of the device was used during data collection. We are currently using the first receiving antenna of the software. Therefore, we will enable RF0. You can also choose the storage size for each channel. Software path. We use the default path. We'll save the file in. The software's path and file name conventions can also be customized. When the collected files are relatively large, we can split the file into multiple smaller files. Then click Start. The collection has now been successfully completed. As can be seen from the file name, device channels, acquisition frequencies, sampling rates, and acquisition duration Then replay. We connect the TX0 to the spectrum analyzer via an SMA cable. Then enable TX0. Add the file you just collected. Click to start. You can see the spectrum diagram of the signal just captured. The operational section of the data collection and storage software has now been fully introduced.